So this video is the one that is on selecting the equation that represents the graph. This one's quite tricky because you will see some functions that you're not used to seeing. I think you will see a square root function or two on this one. But also what you'll see in here is you'll see that some of these have a negative with the x. So let's go through this really quickly. If I have a negative a, that's going to flip it horizontally. Horizontal. If I have a negative in front of the x, it's going to flip it across, flip across the y-axis. Okay? So how you know if it's been flipped across the y-axis, so that would be like this is a decay problem, and we know it's decay because it is approaching a line. All right, so this is a graph that's a decay graph. And so because it is approaching a line, then it is decay. So what we do is we look over here at our factor, our b, our base. So if it's supposed to be decay, remember our base, that's being raised to the exponent, should be a fraction. That's in between 0 and 1. So for example, in this case, 1/2. 1/2 is in between 0 and 1, so it is a b that would show us decay. If I had written this as 2 instead of 1/2, then I would need a negative in front of that, x. So think about what this means. Remember, a negative exponent means we take whatever the base is and we invert it. So if this is 2 over 1, then a negative x is going to cause that to be 1/2, which is what we have right here. So this one is written correctly for decay. But if we look at our graph, and our graph is supposed to be decay, and if our graph is decaying, but our base is a whole number like 2, then we need to look for the one that's got the negative x in front of it, all right? But in this case, it's written correctly because this is a decay problem, and all of our choices here are 1/2, so all of those are right, okay? So we could automatically mark out these two because we don't need that negative x. So we're down to these two choices. The negative in front, remember our graphs for decay are supposed to be starting up top and going this way. All right, in this case, our graph is starting from the negative side and going up. So that means the negative needs to be there. It is decay, so those are right. And then the next one that we need to look at is, are we adding 1 to the x, or are we adding 1 to the n, to the y-intercept, or moving our graph up and down? And here's how we know which way we're doing this, all right? Remember, on our exponential functions in the past, we have said that those things are approaching 0. So now this graph is approaching 1. So because this graph, and I'm going to erase some of this so we can see it. So for this one, since our graph is approaching the line y equals 1, that means our graph has been shifted up 1 unit up. All right, so we want the one that says 1 unit up, not the one that says 1 unit left. This one's 1 unit left. This one is 1 unit up, so we want the one that is 1 unit up. So exponentials are a little tricky on that, but this is, again, just to remind you all how transformations affects graphs.